All right. So what do we always do when we factor? What's the first thing we always think about? GCF. Do we have a GCF? Yes. What is it? Good. 4x to the fourth. Very good. All right. So we have a trinomial left in the parentheses, right? Can we factor that trinomial? Yeah. What are the factors of -6 that add up to 1?
3 and 2, -2.
3 and -2, right? So what's the step now to finish by solving it? How do we solve it now? Now that we have it factored. Right, set each factor equal to 0. So we've done a lot of these for did it just freeze on me? I think it did. We've done a lot of these for quadratics, but these polynomials, we have to sorry for the technical problems. So we just have more solutions, or we call them zeros for the problem. Sometimes they call them roots. It's not showing. What's the deal? No. All right, so there's more than 2 answers like the quadratics. Usually they just had a degree of 2. We had 2 answers. All right. So if it's got a degree of 6 like this, there's usually 6 zeros or roots. Okay, we'll talk about multiplicity here in a minute. But sometimes our roots, our zeros, work more than one time. But in this problem, this 4x to the fourth, if we divide by 4 both sides, you'll see that the answer is 0. But most of you knew that anyway, without dividing both sides by 4. Okay? Actually, it's x to the fourth. What times itself 4 times is 0? We have to do the fourth root. There's only one number times itself 4 times it's 0. 0, right? That's why the answer is 0. Okay? So, again, you're used to doing quadratic, degree of 2. These polynomials have degrees of 3, 4, 5, 6, and so on. All right? So, factoring is one method that we're going to solve these. Okay? So, when I want to factor this one, solve it, what do I got to do first? Yeah, move that 26x squared over so it's equal to what? 0. Where's the 26x squared go? In the middle, right? Put it in the right order from highest degree down to your constant, lowest degree. Now, are there factors, or is there GCF, first of all? No. Are there factors then that's trinomial? Are there factors of 25 that add up to -26?
Yes.
What are they, Ryan?
-25 and -1.
Good. So, -25 times -1 is +25, and -25 plus -1 is -26. But I got an x to the fourth for this one. So what's in the front of both of these? Yeah, x squared. Okay, so don't let that x to the fourth mess with you. Just take, split that exponent in half. Okay, is that finished factored? No, those things are called what? Yeah, those are difference of squares, right? So for this difference of squares, I make two sets of parentheses. And for the second difference of squares, I can make two sets. So we're going to end up having four factors, which is what we expected anyway. It's x to the fourth, right? So we take the square root of x squared for that, square root of 25. Then what? Plus and a minus. Very good. And the same thing here. Square root of x squared, square root of 1, plus and minus. So what are my four zeros? My four roots? Negative 5, positive 5, negative 1, positive 1. You know, last week we could find the zeros by graphing, right? Where did we look for the zeros? Yeah, on the calculator, but where did we look to answer that question on the quiz? Yeah, we're across the x-axis, right? Okay, so this graph would cross the x-axis at negative 5, positive 5, negative 1, positive 1. Does this look like a W or an M? What's the end behavior? What's the far right doing? Going up. What's far left doing?
W.
So it's a W, right? If the two ends are going up, it's a W. If the two ends are going down, that'd be an M, right? Okay, and we have to find, what's our y-intercept?
25.
25. What's our max value? It's a W. And the y-intercept's 25. Isn't that 25 also? Yeah.
Yes.
Okay. So then our mins, we have to use our calculator to find those. Right? We wouldn't have to use our calculator, but that's what we did. All right. So, you know, you can use your calculator still if you want. You know, if it asks you to factor it, I want you to factor it. But if it just says find the zeros, you don't have to factor it. You can just look at the calculator like we did last week. Okay. All right, so sometimes a polynomial equation has a factor that appears more than once. This creates a multiple root or a multiple zero. In the polynomial 3x to the fifth plus 18x to the fourth minus 27x cubed equals 0 has two multiple roots, 0 and negative 3, or two multiple zeros. The multiplicity of root r or 0r is the number of times that x minus r is a factor of the polynomial. When a real root has even multiplicity, which means it works an even number of times, 2 times or 4 times or 6 times, those are even numbers, right? The graph touches the x-axis but does not cross it. What did we call that last week? When it touched but didn't cross. Bounces, right? So if you're looking at a graph and you see the graph bounce off the x-axis, that should tell you that that 0 works at least 2 times, an even number of times. Okay? When a real root has odd multiplicity, meaning it works greater than 1, meaning it works 3 or 5 or 7 times, the graph will bend as it crosses the x-axis. So it still crosses what we said last week. All we said last week is if it crossed or bounced, right? If the exponent in our problem was even, we said it bounced. If the exponent in our problem was odd, we said it crossed. Well, if it bends as it crosses, it means that 0 works at least 3 times, an odd number of times, 3 times or 5 times. If when you're looking at the graph on your calculator and it just goes straight through the x-axis, that 0 only works 1 time. So you're looking at your graph to see if it goes straight through the x-axis, meaning it works once. There's no multiplicity. If it bounces off the x-axis, it works at least twice. It has even multiplicity. And if it bends as it crosses the x-axis, you know it works at least 3 times as a 0. All right, it has odd multiplicity. Okay, so let's look at a picture of a graph. Okay, so this graph bounces off at -3, 0. So I know that this has even multiplicity, so it works at least 2 times. Okay, they say it has a multiplicity of 2, so they told us that. All right, as it crosses at 0, 0 here, you can see a little bend in it, right? That means it's going to work at least 3 times. Okay, and they say in the problem here it works 3 times. So this degree of this polynomial, this graph, is a degree of 5 because it works 3 times at 0, 0, and it works 2 times at -3, 0. Okay? It says you cannot always determine the multiplicity of a root from a graph. It's easiest to determine multiplicity when the polynomial's in factored form. So if it's in factored form already, you just look at the exponents and it'll tell you if it has even or odd or no multiplicity. Like that last problem on our quiz last week. Okay? That was in factored form, like this example here. Okay? So what's the 0 for the first factor there? 5. Okay, since the exponent's 2, it has even multiplicity. So if you put a little 2x next to it, that tells me you know it worked twice. Okay? If I was looking at a graph of that, it's bouncing off at that 5. All right? You know, if you were looking at the graph of that, it bounces there. All right, what's this 0? Anybody? -2, isn't it? And how many times does it work as a 0? 3 times. All right, so it has odd multiplicity. So when it's in factored form like this, you just look at the exponents to tell me it's got even or odd multiplicity. When it crosses, though, if you were looking at this graph, when it crosses, it's bending as it crosses. Okay? What about that last factor? What's that 0? -4. Does that have any multiplicity? No, there's no exponent up there. So if I were looking at the graph, it crosses, and it's straight through. It won't bend as it crosses. Okay? So the next type of problems, they're just going to say, find the zeros and state the multiplicity if there is any. Just punch them in your calculator, look at the graph, and it'll tell you what's going on. All right? So here's a polynomial, has a degree of what? What's the degree of this? 3, thank you. It's not that tough to answer that. I don't remember.
I don't remember. I didn't even. I do the highest.
Go with your gut. Your gut's always good.
I guess that's the dropout.
Well, you can do that too, but that's not a good gut. All right, so here's a picture already. I already have the picture on your graphing calculator. What's it doing as it's crossing here? It's bending. So what's that telling you? So it works at least 3 times as a 0. Do you understand that? Okay, it has odd multiplicity because it's bending as it crosses. Okay? So we just punch that in our calculator and that's the picture. Okay? When we looked for the 0, second trace 0, left bound, right bound, it gave us that 0. Okay? Or we could go to the table, remember second graph, and look at the y column, and wherever there's a 0, look to the left, that gives you your 0. Right? It's the x value. Okay? So how do I check to make sure that it works 3 times? Use synthetic division, okay? So I put -2, because that's what we figured out from the calculator, what the 0 was, in our little corner. And do I need to add any zeros? I got an x cubed, an x squared, an x, and a constant. Do I need to add any zeros? No. So I put a 1, 6, 12, and 8 next to my little box. 1, 6, 12, and 8. They were all positives, right? Yeah. Make sure there's no negatives. And then do our synthetic division. -2 times 1 is -2. What am I supposed to do with those two numbers? Add. That's a 4. -2 times 4 is -8. When I add, I get +4. -2 times 4 is -8. When I add, I get 0. That tells you when you get a 0 that it is a 0. So you're expecting to see that. Okay? So we're just going to do it again. So we don't start over. We just put a -2 in front of that row. And we do the same thing. But you don't have to go make your line over the 0, just to the last number that's not a 0. 1 times -2 is -2 again. 4 plus a -2 is a +2. And -2 times a +2 is -4. When I add those, I get 0. So it does work a second time. Okay? So let's see if in fact it works a third time. That's what we're expecting because it bended as it crossed. -2 times 1 is a -2. Did I get 0 for remainder? Yeah. So my 0 works 3 times. Okay? So it has a multiplicity of 3. So when you put that 3x next to the -2, you're telling me it has a multiplicity of 3. You don't have to write out like they do. Has a multiplicity of 3. You don't have to write it all out. Just put it in parentheses how many times it works for me. Questions? All right? I could put it in factored form then. Since -2 works 3 times, this factored is x plus 2 times x plus 2 times x plus 2. Or x plus 2 cubed. All right? So that's a way we can figure out how to factor if we have to. But I'm not going to make you do that. All right, here's another one. All right? How many zeros or roots do you think we have? 4. Why? Because of that exponent, right? That degree of 4. Okay? So, go to your y equals x to the 4th plus 8x to the 3rd plus 18x to the 2nd minus 27. All right? And then watch the graph. When I hit graph, see if it goes straight through, see if it bounces, see if it bends. All right? So pay attention as it draws it. It goes fast sometimes, so you got to be ready. It bent there and went straight through there. So, what am I thinking the multiplicity is there on the left, that negative number? At 3, right? Odd multiplicity. What am I thinking at that positive number there? It only works once, right? It looks to me like -3 and a +1. Where could I check real quick to make sure I'm right? The table. So hit the second graph for table. -3, there's a 0, and +1, there's a 0. So I was right in thinking that. Questions so far? So here's what I'm thinking. At -3 and at 1, and I'm thinking this works 3 times. Okay? Because it's bending. What's 3 plus 1? 4. There's my 4 zeros. Okay? To check to make sure, I should do the synthetic division, but I'll save us the time and let you know it does work 3 times. Okay? When you don't see a total of, in this case, 4. You know, if you're missing some, you're going to have to use synthetic division to simplify your polynomial. And you should always be able to simplify it down into a quadratic where you get an x squared. Then you can go and use your quadratic formula to find your other zeros. Okay, so let's look at another one. Again, your calculator is doing a lot of work for you. I mean, so it's x to the 4th. This time it's minus 8x cubed plus 24x squared minus 32x plus 16. So watch the graph, see what happens. It looks like it bounced, huh? That looks like a positive 2, so I'm going to go to my table. And yeah, positive 2 is the 0. Now, when I see it bounce, I know it works at least how many times? Twice. But I'm looking for how many zeros? 4. So maybe it's for an even number. Yeah. So maybe it works 4 times. Okay. So I'm going to put a 2 here. I got a 4, 3, 2, 1 constant. So I don't have to add any zeros. So, oops, why did I put a 2 there? Kennedy, what goes under the negative 8?
2.
Good. What goes here now, Kennedy? Good. What goes up here?
12.
Negative 12. Good. What's this?
Do I have to do every single one?
Yep. I'm waking you up. You look a little sleepy.
Whoa.
Good. What's 2 times 12? 2 dozen.
24.
Good.
Negative 8.
Good. What's 2 times negative 8?
16.
Negative 16. What do I get?
0.
Beautiful. It works, right? Was Danny telling you? I don't think so, was he?
No.
Not this time? Why do I keep doing that? Because I'm multiplying before I put that one down.
Where did you get that to?
Which 2? This one?
Mm-hmm.
Right here. From my graph. Right here. From my table. Scotty! What goes here?
2. Negative 4. Negative 8. Negative 4.
Positive, isn't it?
Positive. 8. 0.
So that worked twice, right? We should check, because it could be 4. I'm looking for 4. I can only see the 1 on the graph, so maybe 2 works again. If it doesn't work again, then I would do x squared minus 4x plus 4 and solve using the quadratic formula. Okay? Remember, this started out as x to the 4th, so this one here is an x cubed, this one here is an x squared, this one here would be an x. All right? Mr. Jenkins. Did you say 2?
Yeah.
Okay.
I and then 2. I and then negative 5.
Negative 4, you said?
Yes.
Okay. So it works a 3rd time. So it probably works a 4th time, right?
Yeah.
Oh, this is riveting.
Yeah.
And it does. You guys can tell already it does, right?
Oh, yeah.
So what's my multiplicity then?
4.
4x. And we knew it was at least 2, but it could be 4 because it was x to the 4th. That doesn't happen very often, that many times, but this time it did. Okay? So do we have questions on how to find the zeros? Just use our calculator, right? There's one I think you have to do by factoring. The rest you can use your calculator. All right, find the zeros, give me any multiplicity. Remember, if it bounces, it has what type of multiplicity? Even. If it bends, it has what type? Odd, right? Which means even means at least 2, odd means at least 3 times it works, okay? And you want to find whatever your leading coefficient, your degree is, that's how many zeros you want to find, okay? So, there you go. 5 problems.
That's about
4, 45. Good jump.
I gotta go.